Everybody must have slept in this morning. You are
No, we
just got out.
just got out.
But we all gave presentations, so it went longer than
Gave presentations in what?
AP Lit.
Ah,
I don't know where Mallory is because she's not in there, but Hannah, that's probably where Hannah is.
okay. All right.
Did you get my email?
I did.
Okay, just making sure.
Oh, this is curious. Let's see.
That's mine.
Yep. Oh, so it's in your email. Trying to look for a way to rotate it, but
I could just send another one. I have it right here.
Well, why don't you
Take it landscape.
Well, I'm here. I'll just do this. Save as picture. And we'll call it, who are you? Grace Rose. Now I should be able to just open it. And that's not where I put it. Well, for pity's sake, maybe we can just
try looking at your downloads.
Well, I can do that. But I thought I put it in a file that said pictures. Oh, and okay, so I closed that even.
Nope.
Put it in some kind of a picture folder, but I don't know what picture folder I put it in. That's annoying. Oh, there it is. All right, so there's Grace Rose's, and there's Josh Heath's, and here's Hannah Doro's, which again is sideways. All right. So is everyone here? Yep. Mies, can we hear you today? Nope.
I don't know.
Oh, yep. There you are. Okay.
I took a picture of your cow yesterday.
Pardon me?
I took a picture of your cow yesterday. It
Yes.
was the part where the head was literally just sticking out the cow, and it looked really funny.
Yeah, Doro did her little picture of the picture. So that was kind of cool. All right, so let's see. Heath is the other one. All right, so let's look at these. I think it's kind of interesting that we've got 3 different versions, although these two aren't all that far off. It's just that, all right, I don't know whose this is. I don't have, when I saved them to file, I lost it. And I'm going to take a minute and mute you guys because I'm getting an annoying echo here. And you can unmute yourself when I ask questions or whatever, but for now. All right, so whose is this? Raise your hand. All right, so Grace Rose, amount of glucose, milligrams per deciliter per person after eating. Pretty good title. Glucose, milligrams per deciliter, time after eating, in hours, got a key, person A, person B, color coded. What you could have done, wait a minute, what just happened? Because I just lost my thing where I can draw. What could have happened is, wow, that's a big fat line. You could have just started like here someplace and left this part of the graph off. I mean, it doesn't really make it wrong, but if you've got a big area where there's nothing, you don't need to use that. Otherwise, looks reasonably good. Don't have any pen. Oh, there they are, hiding in this picture. So let's make this a little more reasonable size-wise. So probably could have done a little more of a line like this for the best fit, a little closer to straight. And if you look at that, if you do that, then that picture pretty well matches this picture, which is Doro, I think. Is this Doro's picture? Graph? Yep. All right, so, okay, we've got the thing in the way. The amount of glucose left in an individual's blood after hours. And okay, notice how she started at 120. Back to fat. Started at 120. So we don't have the big empty space down there. Time after eating in hours, and glucose in milligrams per deciliter. Legend, all that looks good, looks good. And we have these two graphs being pretty much equivalent. Now, why? You're going to have to unmute to answer this. This graph, we have a fairly low hump in our curve. This graph, we have a fairly high hump in our curve. Why? Does that mean there's a difference? A significant difference in the data. Why is it different? It's a really simple answer. Anyone see why it's different?
One of them included the top like dot, and one of them didn't, it looks like.
Okay, well, That would make a little difference.
Maybe just like our spacing.
Ooh, your scale, your spacing.
Yep.
Notice the distance between, what's that, 220, 230, 240. So notice how close together this is as opposed to this. And that makes no difference in the rightness or wrongness of the graph. But it is worth noting that you can make a graph look a lot different by how the scale is laid out. And it is very important to check the scale rather than say, whoa, look at how high that hump is or how steep that curve is. The scale can affect that, so we need to be careful. Now, I thought I had that open. There it is. Oh, so basically, let's see, what am I in? I'm in charts. I should be able to. I'm in. I think if I do this as a reply, wow, look how huge that gets. Go away, you're not helping me at all. All right, this is not being helpful, so I'm not gonna keep going with that. We've got time after eating on the y-axis, and time is always the independent variable. So time is always on the y-axis because nothing we do affects time. Things may happen over time, but we can't change time. So when time is involved, it is always on the x-axis. And if we imagine this whole graph being rotated counterclockwise 90 degrees, here would be where our straight line is, and here would be our humped line. And so we end up with basically the same graph as everybody else had, just laying on its side. But we do have titles, glucose tests after eating cake. Could be
I just decided to have a little fun.
So the cake you added, or I don't know, did it say what they were eating in this cake?
It was, I said Coke. It's supposed to be Coke. I'm a terrible legible handwriter type deal.
Well, yes, we that's not news to us. And we still love you, so you know it's all good. But you've got your key, person A, person B. Needed a scale on this one. Probably could have used a slightly better title, a little more complete title. But other than this wrong axis, not too bad. So now that we've looked at that, we've got this list of questions and we can refer back to the graph if we need to. All right, now number 10, and I don't think let me check back here. Okay, they didn't tell you anything else about the experiment. They didn't tell you what they were fed, if they even controlled what they were fed. But what individual would you potentially diagnose as diabetic? Somebody, I don't care who, somebody give me an answer on that with a Y.
I would say probably. Go ahead.
Nope, you're good.
Is it the higher amount that they're not regulating it as much? So it would probably be B.
Okay, so glucose is B. B is the solid line, yes. So insulin is supposed to be is it's supposed to control keep the glucose levels from spiking in the blood. And of course, as you go for hours after eating, the amount of glucose in your blood would continue to drop. So yes, it is this person right here, person B, because of that spike. Glucose levels aren't supposed to spike after you eat. That's what the whole purpose of insulin. Somebody have a comment there? Sound like somebody was getting ready to say something. And so we answered this question too. If the time period was extended to 6 hours, what would be the expected blood glucose level for person A and person B? So now we're going to extrapolate. We're at 4 hours. We don't have room on the graph. And I can't write off the picture. So 6 hours would be over about on Mallory's arm the way, well, I guess you guys don't necessarily have the list of pictures all at the same place, so that doesn't make any sense. If we were to extend this out, I don't know if you can see where the blue dot is or not on the screen. See the blue dot with the arrow pointer? Can you see that? Can you see my mouse pointer? Nope. All right, I think I can do this real quickly. So let me change this to landscape and insert picture. All right, now you see the graph on a blank sheet of paper, do you? Is that what's on the screen? Oh, propane guys here. Let's see, I need zoom to 200%. All right, so now I think I should be able to extend this out. So we extend our line here, and 6 would be about there. Whoops. 6 would be about there. And so if we extrapolate this line down at 6, we would have been about, if only I could draw straight lines. Straight lines. Geez, this is terrible. Would have been about there, which looks like on this scale would have been, looks like this would be 100. So it looks like we would have been at about 110 for a person. Who is this?
That
Solid
would have been
line.
100. It would be 115
Okay.
because it's every 2.
Oh, yep. It'd be 115. No? 40, 35, 30, 35, 20. Yeah, okay. So it'd be about 115 for person B. And as far as person A, use different color for person A. Person A, depending on how we would have drawn this first line, would have ended up actually below this scale. So this extrapolation is where all that extra space that Gracie put in might have been handy, but I think we can still make this work. So if we come across like so, that would be 100, 1, 2 is 90, and then, so that would be about 85 for person A. All right, does it make sense? Any questions? What conclusion can you make about the data and graph for experiment 1? That's a pretty open question. What conclusions can you make? Experiment, wait a minute. Oh, experiment 1 is back to the previous graph from yesterday. Okay. So what conclusions can you make from this?
Plant A has more consistent bubbles per minute.
Okay. You could, there's a lot of places you could go. You could make, without knowing the experiment, you're just shooting in the dark on conclusions. And you would have to conclude that there's some other factor other than depth that was influencing the blue line plant. I can't remember which one that is. And I either lost or didn't put a, oh, plant, it's a square as plant B. So something else is influencing plant B, and without any information, we don't know what that is. So that's a pretty wide open question. What conclusions can we make about plant B? I mean, experiment 2, sorry. What conclusion can you make about the data and graph for experiment 2? Which is this one right here. This one, they gave us a little more information. They indicated that there might be a diabetic here. So our conclusion from this one might be that this person is diabetic, and then you would explain because they should be having a consistent drop in glucose blood level, not a spike like that. And if they hadn't hinted about insulin, maybe you would have known enough to make that conclusion, maybe you wouldn't. But that leads us then to this business about interpretation. In addition to being able to draw a graph based on data collected, you will also need to interpret data given to you in graph form. Answer the following questions based on these graphs right here. Note most of these are not great graphs. They're for practice only. I mean, they don't have labels. They don't have hardly anything. Identify the graph that matches each of the following stories. I had just left home when I realized I had forgotten my books, so I went back to pick them up. Okay, so this is distance from home and time. Distance on the y-axis, time on the x-axis. So if you were going to graph this story, I had just left home when I realized I had forgotten my books, so I went back to pick them up. What graph describes that story? Speak to me.
4.
That is correct. They did over in Roman numerals. That's supposed to be IV, not JV. So they're home. They're zero distance from home. Time goes on. They start to leave. They realize they've forgotten their books. Time goes on, they get back to 0, back home, get their books, and then they leave again. Things went just fine until I had a flat tire.
2.
I'm sorry, you said 2, right?
Yeah.
All right, so you leave home, you're getting farther and farther away. Boom, the tire goes flat. You're not going anywhere. Time is passing, but distance is not changing. The tire gets fixed and you head off to school or whatever, wherever you were. Right, number 20. I started out calmly, but sped up when I realized I was going to be late.
1.
1.
That is correct. I was slowly getting away, and then I went faster and faster and faster and was getting away, getting farther and farther, faster and faster as time went on. And is there another question on the next page? No, because you've only got one left, and it would be process of elimination. Graph at the right represents typical day of a teenager. I don't know if it's typical day or not, but we'll pretend like it is. What percentage of the day is spent watching TV? Well, it doesn't tell you. So how do you figure it out?
Add them all together.
Okay, the total has to be what?
13%.
Yeah,
Well, it
but
has to be 100%.
the total has to be 100%. So 33 and 17 would be 50, plus 25 would be 75, plus 4 would be 79, plus 79, plus 8 would be 87. I skipped, no, I got everything. So 100 minus 87 leaves 13%, just like Josh said. How many hours are spent sleeping? Well, how in the world? It says 33%. How in the world do you figure that? How many hours are in a day?
24 by 0.33.
Okay, so 33% of 24 would be,
7.92.
yeah, or 8, because
hours.
it's actually 33.333, and they've got all these rounded, so we'll just 8 is fine. 7.9, whatever would have been fine too. And boom, this is not a typical teenager. No. Typical teenagers do not get 8 hours of sleep. Anything I've heard anyway. This should be easy. What activity takes up the least amount of time?
Studying.
Yep, and I think 4% is probably generous.
Quick off-topic question: Did your kids sleep on your sleep schedule and like help you with the chores early in the morning, or did they do the normal teenage thing?
Yes, but I had a different sleep schedule then. Because I had kids helping me with the chores, I didn't have to get up so early. But basically, they would get up early and then they would sleep in the car on the way in and on the way home, for that matter. So they'd get an hour nap on the way in and probably close to an hour nap on the way home. What activity takes up a quarter of the day?
Sure.
School or live stream.
This is
What?
not a normal day because I'm pretty sure I spend way more than 8% eating, especially during quarantine.
Eating?
Mm-hmm.
Yep. All of us are going to have to buy new clothes when this stupid quarantine thing's over with.
Mm-hmm.
What 2 activities take up 50% of the day? Well, we had our 50 right there by adding these 2. Or you can notice that these 2 are on the right side of the line and the right side goes right down through. 2 activities take up 25%.
Eating and talking on the phone.
Yep. this kind of graph, you folks are going to be much more comfortable with than the line graph. Line graph. Now notice that this is not a smooth curve. This is a dot-to-dot curve. Again, a line challenged. I understand that. This is a dot-to-dot curve, and it is not a best fit curve. Why? Why is this dot-to-dot and not best fit? What did I tell you about best fit curves? What did I tell you about curves yesterday, and that they don't go up and down and up and down? They're almost never wavy. They're almost never wavy in what? I was having an echo and I was muting you, and I muted you. So if you have an answer, you'll have to unmute.
Didn't you say that if they go up and down a lot, they probably should have been a bar graph?
Maybe.
Or is this not the up and down you were talking about?
When I was talking about some of them would, yes, I did say they would go on a bar graph. I think Niece is the one who's echoing on me, and I don't know why. But anyway, either they should be a bar graph or there's something wrong with the data, because natural functions almost never wave up and down. Natural function is almost always a straight line or a steady curve. So the reason that this graph goes up and down is because this is not a natural function. By natural, I mean happens in nature. A trip by car is not a naturally occurring event, which is why this goes up and down. This is hours versus miles. How far from home are you? Now, this can't be how far you traveled, because if it was how far you traveled, it would keep going up. Because unless you did a whole bunch of backing up, but even then, when you back up, you're traveling. So how many total miles did the car travel?
Are we supposed to add all of them together, or is that?
You know what? This is not the kind of thing that we should expect to see on a biology test, because how far did it travel? Well, it traveled. You cannot answer the total miles the car traveled on this graph. Maybe you can, but I don't know. Because this is miles what? From home or from the starting point? You can't tell how many miles the car traveled. You could assume that it traveled 53 to there, but then from here to here, is it standing still or is it going in a circle? Because if it's going in a circle, it's still the same distance from home. So you can't tell how far it traveled. Describe the motion between hours 5 and 12. Well, either it was standing still or it was going in a circle. What direction is represented by this? It's back towards the only question here that is really valuable for the kind of graph you will see is how many miles were traveled the first 2 hours of the trip, which would be right here, and here would be, each of these blocks is 10, I guess, so 20 hours. That is a bad illustration for what we want to know. You will see bar graphs. The bar graph at the right represents the declared majors of freshmen enrolling at a university. What is the total freshman enrollment of the college? Well, you've got 100 and we're going to call it maybe 52-ish, and maybe 149, and approximately 325, and approximately 230, and maybe 225. Now, notice these are all approximates, so you can be in a ballpark range here. So this is about 300, 625, 855, 1,000, and there's about 1,050. About. So now the rest is math, which you can figure out. What percentage of the students are majoring in physics? So 149, or let's call it 150, over 1,050, you know how to figure that percent. And the same thing for economics, except it would be 325. This is simple math, you know, that you're familiar with. How many students major? How many more students? Again, the difference between the two bars. That's the kind of thing you should be comfortable with. Now, here's an example. Rainfall is a natural function. And it may be that this one could have been better illustrated in a bar graph. So we have 1989 represented by this line with the little triangles, and 1990, the line with no triangles. And this you should be perfectly comfortable with. How much rain fell in March in 1989? So March to the 1989 line, about 5 inches. How much rain fell in February how much more rain fell in February 1990 than February 1989? So February 1989, if only I could draw straight lines, would be about 2 inches. And February 1990 would be about 4 inches. So 4 minus 2, about 2 more inches fell. Which year had the most rainfall? Well, here you would have to say January was about 2 inches, and February was about 4, and March was about maybe 3, April just over 6, May 4.5 or 5, and June maybe 7. So that would add up to 10, 22 inches. 22 inches for 1990, and you get the idea. I don't think we need to do any more. What is the wettest month on the graph? What is the wettest month on the graph? It's going to be tight. This is where a ruler comes in. Between this and this, I think visually that this one is higher. So what is, now somebody answer me, what is the wettest month on the graph?
April.
Well,
June.
it's either April or June, but that answer, neither answer is good enough. It's either June 1990 or April 1989. You see why June and April weren't quite good enough answers?
Yep.
Okay, so line graphs are most often used to show continuous change. And that's why the line graph was probably not the best graph for the month or for the distance traveled in the car, because those are not continuous change. There we are. In the example given above, both the year and the populations are variables. The factor which is changed or manipulated in this case is the year is called the independent variable. The measured effect is the dependent variable. And again, time is always the independent variable. I want you to look over these pages here. That's page 8 and 9. Okay, I want you to do the rest of these pages 8 through 11, and tomorrow we will go over them. So we'll end with this. If you have any questions, now's a good time to ask. And who is looking over your shoulder?
Meredith.
She looks different looking over your shoulder than in real life. All right, so you can be done. Finish 8 through 11 for tomorrow. And Josh didn't see the calf born. I hope the rest of you like the calf born. All right.
That was awesome.
All right, you folks have a good day, and we'll talk to you tomorrow.